In this video, we're going to be talking about section 1.2, and that's actually part 1. We'll be solving equations, and today we're just going to do very basic one-step equations just to get everybody off on the right foot. And I want to stress that the important learning here is not the answer. Like I don't particularly care about the answer to any of these questions. That's not the point. The point of this exercise is for us to understand the basic steps in solving equations. And just like learning any new skill, we got to be proficient at the basics before we get more difficult. So almost every question that we do today, you'll be able to probably just do in your head, but that won't help us once we get to more difficult questions. So please stay with me and play along, and let's make sure we understand why we do the things that we do, and that'll help us understand things when it gets more difficult. All right, so to begin, I want us to look at this scenario here. So warm up number one, I just want you to quickly write, and you can use bullet points. What are the steps to wrapping a present so that it looks like the one pictured in this image? And I want you to think about the fact that you have the gift itself, the item. You're going to have a box. You're going to have ribbon. You're going to have paper, maybe some tape, right? I don't need you to write a thesis here, but just like what would the logical steps be? So go ahead and pause the video and just write down the steps and visualize yourself actually wrapping this present. Okay, so I think the first thing I would say if I was wrapping this present is, and again, we could get ridiculous and say, take the tag off the box. But I'm going to put the item. So put item, the actual gift itself, put gift in box. And then, I don't know, I'm going to be a little silly here. I guess I'll say put lid on box. And you might not have these, that step. That's fine. I'm going to say wrap with paper. And let's maybe say put tape the paper. And I think we'll just call it good and wrap it with ribbon or do the ribbon, ribbon it, whatever, use ribbon. Okay. So we have wrapped our box. And now I would like us to think about how do we unwrap the box. And so, and again, you're not a monster. You're not just going to tear into this thing. Let's unwrap it. Like, let's say we wrapped it and like, oops, we forgot to take the tag off. So now I want to delicately unwrap this so I can get back and take that tag off, right? So, yes, one answer could be go nuts and tear it to shreds, but let's not do it that way. So the first thing I would want to do is, and maybe I'll go back here and be more specific. I'm going to say tie the ribbon. Okay, so then the first thing I'm going to do to undo it would be the last step that I just did. So I'm going to have to untie my ribbon. And then I need to untape the paper. And after that, I'm going to unwrap the paper. And take lid off of box. And then I'm going to, I guess we're at the stage where I remove the gift. Remove gift from box. All right. So I want us to think about equations, solving equations very similar to this process. On one hand, we know what the item is. Like we've started with this known gift, and we have then wrapped it to a final answer, essentially. And in solving, in step 2, unwrapping the present, essentially we have a wrapped gift. We have an answer to an equation. And our job is to figure out what's that gift. What was that variable? What was the x value that we used at the beginning? So on one hand, we plug a number in and get an answer. And on the other one, we have an answer. We try to figure out what the number was. And that is the relationship that we're trying to connect between these two. All right, so let's see that kind of in action. So wrapping the present. Wrapping the present would be as if we know what the gift is. In this case, our gift is X is 13. So we know what the item is. We know the number. To quote, wrap the present, we would plug in 13 and then just do all the steps. So plugging 13 in for X would give us 3 times 13 minus 6. So this is a two-step wrapping of a present. So the first step is multiplying it by 13, following the order of operations, right? So that's like us putting it in the box. So that's 3 times 13 is 39. And then the next piece is putting the ribbon on the box, if you will, and that's like subtracting 6. And we have our final wrapped present of 33. So we did our two steps, which were multiply by 3, and then our last step was we subtracted 6. All right. So now let's look over to the right here where it says, what is the solution to this equation? And now it's as if we are going to unwrap the present. So please notice the setup. I've got the same 3x minus 6, but at this time, instead of telling you what x is, I'm telling you what the final result is. So we know it's going to equal 33. So now the question is, and we already know the answer is going to be 13, but if we didn't know the answer was 13, how would we get to it? And so if you look over here, we subtracted 6 as our last step to get to the 33, right? So then our next step has to be the undoing of subtracting 6, our first step in solving. So looking back at our steps here, our last step here was tie the ribbon, right? That's doing of tying the ribbon. And the next step is the undoing. Oops, that's not what I wanted to highlight. Right here. Our first step in solving is to untie. So we undo the thing that we did. And so if on one hand we subtracted 6, over here, we're going to add 6. So we're going to add 6 to 33. And then our first step over here was to multiply by 3. So we have to undo a multiply by 3, which would be to divide by 3. And so I get x equals 13. So we have unwrapped the present. And we've done it in the opposite order. Okay, so I want you to really focus on that. Order of operations tells us we have to multiply first and then subtract. Well, that's if we know what x is. Well, if we're trying to find x, we have to do things in the opposite order to undo it, right? So now we're not going to follow the order of operations. We're going to do the opposite first. We're going to deal with the subtract piece first, and then we're going to deal with the multiplication piece. All right. We will talk more about this. Let's keep moving. All right. A lot of space there. Okay. Two concepts here that we need to discuss. The first is this concept of an identity. There is something called an additive identity. Is there a number you can add to any number that won't change its value? So, for example, I have the number 6. What can I add to 6 and have it still equal itself, like its identity? And the answer, of course, would be 0. I can add 0 to any number and it doesn't change it. All right. And is there a multiplicative identity? Is there a number you can multiply by any other number that won't change its value? So in this case, can I take 6 and multiply it by some number and have it not change what it is? And it's not 0 anymore, right? Because 6 times 0 definitely changes it. The answer, of course, is 1. So the additive identity is the number 0. 0 is our additive identity, and our multiplicative identity is a 1. All right. Connected to that is this idea of additive inverse. What can you add to any number to another number to get the identity? So for example, if I have 6 and I'm going to add something to it, and I want to get, as a result, this number we identified over here as the additive identity. And the answer, of course, is the opposite, right? So adding a -6, or said another way, 6 and then subtract 6 would get us our answer of 0. So the inverse, the additive inverse, is you could think of is subtracting, or you could think of as adding the opposite. So to get the additive inverse, you're going to add the opposite, which is just the same as subtracting the number. All right. And then the multiplicative inverse is how we take a number and turn it into the multiplicative identity. So how do we take a number, say 6, and what do I do with multiplication to turn it into the multiplicative identity? And so the answer to that question is we would have to multiply by what is known as the reciprocal. So if I multiply 6 over 1/6, then I get 1. So I can multiply by the reciprocal. Another way to think about this is if you want to find, if you have a number like 6 and you want to find the identity, the multiplicative identity of 1, you can, instead of multiplying by the reciprocal, you can just divide by the number itself. So you can think of it as multiplying by the reciprocal, but that's exactly the same as just dividing by the number. All right. So those two concepts work together, and they're essential in our solving equation steps, even though you may not realize it. All right, let's go down and take a look. How do those definitions help us? All right. So when we're solving for x, what we want to do is we want to know what x equals, right? So our goal is simply to make it so our equation doesn't say x plus 6, right? Right now it says x plus 6 equals. I don't want to know what x plus 6 equals. I legit just want to know what does x equal. And so if we take a look and analyze this problem, we ask ourselves very simply, what has happened to x that we don't want anymore? And what I want to do is make them go away. And so the answer to what we do always lies on the side of the variable. And so x plus 6 equals 5. What I want to do is I want to turn this into x plus 0, meaning I am going to use the additive inverse, which is adding 6. The additive inverse is to subtract 6. And the reason I want to do that is because now when I add these together, I get x plus 0. Okay, and we'll worry about the other side in a minute. And why do we like x plus 0? We like x plus 0 because, so we did the opposite here. We did the additive inverse. And why was that helpful? Because that gave us our additive identity. And why is that helpful? Because now when I add those together, x plus 0, of course, is just x. So those two concepts work together to get x by itself. We removed the 6, and we're left only with the variable x. Now, one other concept, of course, is that we have to be balanced. So think of an equation as like a balanced scale. And so on one side, because right now I'm telling you x plus 6 is exactly the same as 5, so they're balanced. See like a two-handed balance. And now I've just taken 6 away from one side, so we're not balanced anymore. So then the only other thing I need to worry about is retaining that balance. So whatever I do to the left side, I have to do to the right side. So I'm going to subtract 6 over here as well. And so 5 minus 6 is negative 1, and we're left with now negative 1. All right, and I realize like it seems like I'm making this more complicated, but I'm just trying to show you like why we do the things that we do, which will become instinctual and you'll just do them. Okay, 2x equals 15. I don't want to know what 2x is. I want to know what x is. So I'll know what x is when, once again, x is by itself. So I have to make this 2 go away. And the way we make that 2 go away is by using the multiplicative inverse. In other words, I'm going to take my 2x, I'm just going to rewrite it to give myself some space, and I'm going to multiply by 1/2. I'm going to multiply by the reciprocal of 2. Because 2 times 1/2 is going to get me 2 over 2x, and I'll worry about the other side in a minute. And why is 2 over 2x important? Because 2 over 2 is 1x, and that means we have created, right, the multiplicative inverse. What can you multiply a number by to get the multiplicative identity? So our goal was to get this number 1. Because now that we have done that, that's the identity, and 1 times x is x. And so now we got x by itself. So that's why we look to the left side of the equation to tell us exactly what to do. We need to unwrap this present. Someone has multiplied it by a 2, and the thing we do to unwrap it is we then multiply by 1/2, the reciprocal of that. So then what do we do on whatever we do on the left side, this multiply by 1/2, we have to do on the right side. And so that gives me 15/2, which is a perfectly fine answer. And so my answer is 15/2. Or if you prefer a mixed number, which I do not, you can divide 2 into 15, goes 7 times with a remainder of 1. So x is also equal to 7.5. Okay. So that's what we're doing. Let's go through and do some examples together. And we don't have to be quite as show all those steps. So here we go. I have b minus 5 equals 7. I don't want the minus 5, so we need to undo that, and that would be adding 5. So we're going to add 5 to the left side. Negative 5 plus 5 cancels out. We're left with b equals, oh, by the way, we also have to do it on this side, and we get 7 plus 5 is 12. Number 2, it's got fractions, so we need to be able to do our fractions. Also, we have 2/3 plus a instead of a plus 2/3. But since the 2/3 is positive and the a is positive, this is exactly the same thing as just saying a plus 2/3. So if you prefer to write it that way, please do so, okay? But it should be fine to solve it as is. I want the 2/3 to go away, and so the opposite of 2/3 is adding 2/3 is to subtract 2/3. What we do on one side, we do on both sides. And now 2/3 minus 2/3 is 0. 0 plus a is a. And now I just have to answer, and I'm going to come off to the side. What is 1/4 minus 2/3? So quick review, I need a common denominator. So looking at common multiples, so 3 can be a 3, 6, 9, 12, etc., etc. 4 can be 4, 8, 12. And notice they can both be 12. So what I'm going to do is I'm going to turn this into a 12 by multiplying the 3 by a 4. But I can't do that because I just changed the problem. But what can I do? I can multiply by that identity. Multiplying by 1 or 4 over 4 won't change 2/3. It retains its identity. And then I need to turn the 4 into a 12 as well, so that one needs the 3 over 3. And so I simply get 3/12 minus 8/12. And when we add subtract, we don't change the denominator. That's why we got a common one, and I get negative 5. 3 minus 8 is negative 5. The answer is negative 5/12. All right, if you are weak with adding and subtracting fractions, which many of you are, please make sure you communicate that to me so we can maybe spend some SST time getting that figured out. All right, so now we have multiplication. So to figure this out, we need to do the opposite of multiplying by 4. I would like to think of this as multiplying by the reciprocal. So we have 4x equals negative 20. I need the 4 times to go away. And what's going to accomplish that? It's going to be taking 1/4, I'm just going to rewrite it here, times 4x, because a fourth times 4 is simply 1x, right? 1/4 times 4 over 1 is 4 over 4, which is 1. And 1 times x is just x. And so on the right side, we have to do the same thing. So I'm going to multiply by 1/4. And that's going to give me a negative 20 over 4, which is negative 5. All right. Now we have negative 5x over 3 equals negative 25. The best way to approach this question is let's separate this and understand that negative 5/3 x is exactly the same thing as just having a negative 5/3 times an x equals negative 25. Because if I multiply them together, what do I get? Negative 5/3 times x over 1, I get negative 5x over 3, which is how it was given to us. So whenever you see a statement like this, we can realize that this is just a 5/3 times an x. Okay, so I want to turn this into a 1 times x. And so I have to multiply by the reciprocal. That's the multiplicative inverse. So I'm going to multiply both sides by, I'm going to start with just 3/5, but I want you to quickly see that won't get the job done because I want to multiply 1 times x. And if I multiply by a positive 3/5, we have a positive 3/5 and a negative 5/3. That's going to leave us with a negative x. So the way we accomplish that, of course, is we're going to multiply by negative 3/5. Negative times a negative is a positive. 5 times 3 is 15. 5 times 3 is 15. So I have 15 over 15, which is 1. So this gives me positive 1x, which is what I wanted because that's just x. And then what I do on that side, I have to do on this side. Negative times a negative, always do those separately. So now I know the answer is positive. And now I just have to answer what is 25 over 1 times 3/5. Now you can multiply straight across and then reduce, but hopefully most of us recognize that I can reduce fractions, any numerator with any denominator. So in other words, 25 and 5, 5 goes into 25 5 times. So I can just reduce here. And now I'm left with 5 times 3 is 15 over 1 times 1, right? When we reduce this, that 5 went into that, and that went away. That's generally easier than doing 3 times 25 and getting 75, and then doing 5 times 1, and then having to figure out what 75 divided by 5 is. Spoiler alert, it's 15. All right, last couple. Once again, I have really just the same question as before. I have a 2/5 times x. I want it to be a 1. And so what's going to accomplish that? Multiplying by 5/2. So I'm going to multiply both sides of the equation by the reciprocal, 5/2, which gives me 10 over 10, which is 1. 1 times x is x. And then over here, I'm looking, and I can reduce the 2 and the 4 first. I could do 4 divided by 2, or I could just do the math, right? So if I just did the math, that would give me 20 over 14. But then I have to recognize that, hey, those are both even numbers. And so I could divide them both by 2, and that would give me 10/7. And that would be the correct answer. All right, and then we get to number 6. X over 3, I hope you recognize, is exactly the same as 1/3 times x. Because if I were to multiply those together, I could stick a 1 underneath. That gives me x on top and 3 on the bottom. So when you see x over 3, you can think 1/3 x. So I'm just going to rewrite that real quick. And what is the reciprocal of 1/3? Reciprocal is we just flip a number over. So that means we're going to flip 1/3 over and it becomes 3 over 1 or just 3. So I'm going to multiply by 3 on both sides. Gives me 3/3 on the left, which is just 1 times x. And 8 times 3 is 24. We can always, I haven't stressed this yet, but we can always go back and check our work. Take your answer, 24, and plug it back in and check it. 24 divided by 3 is 8. That is a correct answer. Over here, we said the answer was 10/7. So 2/5 times 10/7. I can reduce these fractions. This 5 goes into 10 2 times. I multiply, I get 4/7. That's the correct answer. So you can always check your work to see if you have done it right, and then go back and see if where you made a mistake if it's not working out. Okay, I hope this makes sense, and we will talk about it in class if it doesn't.